Hey guys, welcome to my channel again. I'm very sorry for the inconvenience. My laptop ran out of battery. So we will be continuing again from this part. Okay. So we have already done two questions here. We have already done two questions. These two questions were the questions we have already done. Next, we will be doing these questions like what do you mean by a free fall body? Okay, so I'll write it down. The falling of a body from a height towards the earth under gravitational force gravitational force of the earth is earth is called free fall. So it means that the falling of a body is from a height towards the earth under the gravitational force of the earth, and it is called a free fall. So, hence the motion of a particle falling down or going up under the action of gravity means the body is under free fall. Okay. Now, next we have the question: what do you mean by acceleration due to gravity? Now, acceleration due to gravity is or acceleration of a body during free fall towards a celestial body is called acceleration due to gravity. So this is the answer. Number two, gained by a celestial body. A celestial body due to gravitational force. Uh, Next is its what is its value? When we what is acceleration due to gravity? Till here is okay. But if it's what you mean by acceleration due to gravity, then we also need to write the value of acceleration due to gravity. So the value of acceleration due to gravity is 9.8 meter per second. Wait a minute. Meter per second square. So this is the answer of number 2 on page number 136. Next, we will quickly move to page number 138. Okay. So in here, we are having two questions. Okay. What are the differences between the mass of an object and its weight And the second question is, why is the weight of an object on the moon one-sixth its weight? So let's do it. The question is, uh, what are the difference between mass of an object and its weight? Okay. Now you will be writing it as an in part wise. You will draw two columns and write it down. But here I'm not getting space, so I'll just write down. So this is the answer. That first is mass is a quantity of matter, while force is with which to a weight is with force with which an object is attracted towards center of the earth's gravity. Now mass is constant everywhere, but weight changes from place to place. Mass, it is a scalar quantity, while vector is a weight is a vector quantity. Mass's SI unit is kg, and the SI unit of weight is Newton. Okay, mass is never zero, and weight is zero at the center of the earth of free space. Okay, now next question is that why is the weight of an object on the moon one-sixth that of on the earth? Because the gravitational attraction of the moon is about one-sixth when compared to the earth. So it is one-sixth of its. Okay, basically I'll explain it to you what I meant by saying these lines. Okay, so it is, we know that the weight of an object is w equals to mg. Here m is mass of the object and g is the acceleration due to gravity. Okay, so the mass of an object m remains constant at all the places, and acceleration due to gravity changes from place to place. So we can say that the weight of an object depends on the acceleration due to gravity. So on the moon, the acceleration due to gravity is one-sixth that of the Earth, and this is the reason why the weight of an object on the moon is one-sixth to its weight. Clear? Um, next we have next in text question on page number 144. If you want to follow, you can follow. Yes, Sati. I'm doing it from your NCRT. Okay. So here we have, why is it difficult to hold a bag having a strap made of thin and strong string? Okay. So the first thing is that the force that is exerted by the thin and strong string is distributed to very less area, and hence the force applied due to the bag is more. So the pressure exerted on the body by thin straps will be more, and hence it will be more painful. And also it is as pressure is inversely proportional to area. If the area is reduced pressure, it increases. So pressure is directly proportional to 1 by area. Okay, so the answer is here. Next, number 2. In number 2, it is written that what do you mean by buoyancy? Basically, in simple answer, we can say buoyancy is the upward force exerted by uh, a liquid on any object immersed in liquid is called buoyancy, or you know, upthrust. Okay, so this would be the answer. Let me write it down for you. Next is number 3. Number 3 is, why does an object float or sink when placed on the water or surface of the water? Answer is that the density of an object in water decides the floating of, or sinking of the object in water. So the density of water is 1 gram meter per centimeter cube. So the density of an object is less than the density of water, then the object will float. And if the density of an object is more than the density of water, then the object will sink. Right, are you understanding? So we can say that when an object is placed on the surface of water, two forces act on the object. The weight, first is the weight on the of the object acting vertically downwards, and number 2 is the upthrust of the water acting vertically upwards. So the object will float on the surface of the water if the upthrust is greater than the weight of the object. So the object will sink. If the weight of the object is more than the upthrust of the water, upthrust of the water will be more, and it will sink. So this is the answer for number 3. I hope you can understand. Okay, so it is done here. Next we have in the next 142, page number 142. Here you find your mass to be 42 kg on a weighing machine. Now, is your mass more or less than 42 kg? Okay. So the mass is, so we can say that the mass of this, just a second. So the mass of is more than 42 kg, because as the buoyant force due to air is acting on us, and the reading of weighing machine will be less than the actual mass of the person. So measures actually measures the weight as in acceleration due to gravity. Next we have number 2. Number 2 is, you have a bag of, just a second, yes, you have a bag of cotton and iron bar, each indicating a mass of 100 kg. So when measured on a weight machine, in reality, one is heavier than other. Can you say which one is heavier and why? So in this question, we find that the heaviness of the bag can be given by density, which is density equals to mass by the volume. So mass of the both of the cotton bag and the iron bag is same, but the volume of cotton bag is more than the iron bag. So hence the density is inversely proportional to the volume, and the bag of the iron will be heavier. So it will be heavier. So the answer for this is that like so the cotton bag is more heavier than the iron bag, as the buoyant force acting on the cotton bag is more, as its surface area is more than that of the iron piece. So the formula would be density equals to mass by, so it is density equals to mass by volume. So this is the answer. Okay. Next we have is in page number. So this is the end. We have already done the summary in our first class. Okay. Now we will come on to the exercises of it. So the first question of it, give me just a few seconds so that I can do it better. I can explain it to you a little better. Okay. So the first question here, as you can read, is uh, how does the force of gravitation between two objects when the distance between them is reduced to half? So according to the universal law of gravitation, what happens? Uh, that the force of gravitation between two objects is, we know, given by F equals to G into M1 into M2 by R square. So we can say that according to Newton's gravitational law, I'll write it down here for you, that according to Newton's gravitational law, we have the formula that F equals to G into M1 into M2. So the initial force initial force here is, just write it down, equals to F equals to G into M1 M2 by R square. Okay, so we can say, therefore, what would be the final force? So the final force would be, oh my god, this is so, so then the new final force would be equals to, just a second, I've already wrote this, so I'll just copy paste this here. It is R by 2, R by 2 whole square. So it will become as G into M1 into M2 by R by 2 whole square. So it comes as 4 into G into M1 into M2 by R square. So it is hence equals to 4F. So hence when the distance between the objects is reduced to half, the gravitational force increases to 4 times. Next is number 2. In number 2, it says that gravitational force acts on all the objects and the bodies of the in proportion to their masses. So why then a heavy object does not fall faster than a light object? Let's find about it. So as you can see that all the objects, fall on the ground. So all the objects is like acceleration due to gravity, which is small g, is independent of mass of the falling object and is equal for all objects at a point. So a heavy object falls with the same acceleration as a light object, right? So this is why a heavy object does not fall faster than a light object. Now we have got number 3 here. Number 3. Now, what is the magnitude of the gravitational force between the Earth? What is the gravitational force between the Earth and a 1 kg object on its surface? Here also it's written that take a mass of the Earth as 6 into 10 to the power 24 kg and the radius of the Earth as to be 6.4 into 10 to the power 6 meter. Okay, so now as we already know that from Newton's law of gravitation, we already know that the force of attraction between the bodies is given by a certain equation, which is this equation, which is F equals to, okay, so this it is given by this. So here the mass one is, the mass of the earth, which is 6 into 10 to the power 24 kg, and mass 2 is mass of the body, which is 1 kg, and r is the distance between the two bodies, and radius of the earth, two bodies radius of the earth, which is 6.4 into 10 to the power 6 meter. Now g is the universal gravitational constant, which is 6.67 into 10 to the power minus 11 Newton per meter square per kg square. Okay, so what we do is just we put the things in the gravitational force and all those which happen here. So it comes as F equals to 6.67 into 10 to the power minus 11 into 6 into 10 to the power 24 into 1 by 6.4 into 10 to the power 6 whole square. Okay, sorry. So it is given, the masses of the body is given as this. So basically this is how we do it. Okay. Um, next, so this is basically how you do it. Next, we will be moving on to number 4. Number 4 here says that what is the if the earth and the moon are attached or attracted to each other by gravitational force, does the earth attract the moon with a force that is greater than or smaller than or equal to the force with which the moon attracts the earth, and why? So, as we know that when two objects attract each other, then gravitational force of attraction applied by first object on the second object is the same as the force applied by the second object on the first object. So, both Earth and Moon attract each other by the same gravitational force of attraction, right? So we can say that according to universal law of gravitation, two objects can attract each other with equal amount of force but in opposite direction, and the earth attracts the moon with an equal force with which the moon attracts the earth. So this is the answer, that the earth attracts the moon. Basically, it attracts the moon, and it is moon with the same force as the force with which the moon attracts the earth. However, these forces are in the opposite directions, so by which the universal gravitation or by universal law of gravitation, the force between the moon and also the sun can be that F equals to, as we know, F equals to by D square. So in here, where D is, we can say, the distance between the earth and moon, and M1 and M2 is the masses of its purposes. So I think we have got the answer. Okay, so this is the answer. This is the last question of today's class. In the next class, we will be doing from 6 to how many do we have? Okay, we have 22. 6 to 22. We'll do it, but today we will finish number 5 also. So number 5 says that if the moon attracts the earth, then why does the earth not move towards the moon? So it says that the earth does not move towards the moon in spite of the attraction by the moon, because the mass of the earth is much greater than mass of the moon, and is for a given force, acceleration is inversely proportional to the mass of the object. Okay, so it comes as, so this is the answer. So this is number 5. So this is the answer towards the moon. So therefore, so this is the answer. So basically the answer comes as a summary I'll give you, that according to the universal law of gravitation, Newton's third law, all know that the force of attraction between two objects is the same between, however, in the opposite directions of the earth attracts the moon of by the force, same as the moon attracts the earth but in opposite direction. So since earth is larger than, in mass compared to that of the moon, it accelerates at a rate lesser than the acceleration rate of the moon towards the earth. Therefore, for this reason, the earth does not move towards the moon. So I think this is the end of my class. If you like my videos, please like, share, and subscribe, and hit the bell icon so that whenever I'm online, you can join me and learn some new things. In the next class, we will be doing the questions from 6 to 22. So thank you and have a nice day. Your exams are coming, so revise well. Thank you and have a nice day. Bye bye.